In this video, we are going to take a look at the Los Angeles test, which is a measure of an aggregate's strength, or more precisely, its resistance to fragmentation. The principle of the test is quite simple. A 5 kg sample of 10 to 14 mm sized aggregate is placed in a rotating drum along with the 11 steel balls. The drum is then set to rotate for 500 revolutions, after which the degree of degradation is measured by using a 1.6 mm sieve. The more material that passes through the sieve, the less resistant the aggregate is to fragmentation. Now let's take a look at the test in more detail, starting with sample preparation. The sample sent for testing must contain at least 15 kg in the 10 to 14 mm size range. Only material passing of 14 and retained on a 10 mm sieve is used. In addition to this, either 60 to 70% of this material must pass a 12.5 mm sieve or 30 to 40% must pass an 11.2 mm sieve. The sample must be reduced to create two size fractions by using just one of the intermediate sieves. The two size fractions are then washed thoroughly to remove dust, after which they are placed in an oven set to 110 degrees Celsius and dried to constant mass. When cool, the two fractions are mixed together and then riffled down to create a test sample with a mass of 5,000 plus or minus 5 grams. After the balls and aggregate have been loaded into the drum, the front cover is replaced and secured. The power is turned on. The operative then leaves the room, making sure that nobody else is inside. Locks the door. Removes the interlocking key. Places the key into the control box and starts the test. Nobody can now gain entry to the room without removing the key and unlocking the door. If the key is removed, the drum would stop. Inside the drum is a metal shelf that lifts the aggregate and balls, which in turn causes the aggregate to become fragmented. Each ball must have a diameter of between 45 and 49 millimeters and a mass of between 400 and 445 grams. The test is noisy, therefore anyone directly outside of the room must wear ear protection. The test requires the drum to rotate at a speed of between 31 and 33 revolutions per minute. Therefore, it takes about 15 minutes for the drum to complete the 500 revolutions. On completion, the key is removed from the control box. The door is unlocked, and the operative re-enters the room. The power is turned off. The front cover of the drum is then unbolted and removed. The contents of the drum is then carefully discharged into the tray beneath. All aggregate from inside the drum must be removed. The fragmented material is then taken from the tray and washed over a 1.6 mm sieve. It's a good idea to protect the 1.6 by using a coarser guard sieve. This sieving operation is done in several stages to avoid overloading. The retained aggregate is then dried to constant mass, allowed to cool, then weighed. Using this equation, we can work out the Los Angeles coefficient, where m is the mass of the material retained on the 1.6. So in our case, the equation becomes 5,000 minus 4216 divided by 50, which gives a value of 16, as we round to the nearest whole number. The lower the number, the more resistant the aggregate is to fragmentation. For more information on this test, please refer to the standard BSEN 1097 Part 2.